Hi, dear students. Welcome to the online learning platform of the Analytical Chemistry. This is our second lecture of the paper number 13 of B.Sc. third year Analytical Chemistry. In last lecture, you had learned about the environmental analysis. In this unit, we have learned the composition of atmospheric air as well as the sampling of air. Now, in today's lecture, we are going to learn about the determination of particulate matter, suspended and settled, and second one is that the determination of sulphur dioxide. Now, let's begin with this. So, dear students, a suspended particulate matter is determined by means of for this determination, air is passed over a filter paper or a previously weighed filter paper for about 1 hour or for any specified period. The filter paper is then re-dried and weighed. Then the gain in weight of filter paper divided by total volume of gas passed through it gives the total suspended particulate matter in the parts per volume. So suspended particulate matter in milligrams per centimeter cube is equal to milligram of weight of suspended particles, that is nothing but increase in weight of this filter paper after weighing, and divided by total volume into 0.02837 is the Watt conversion factor, and then we'll get the suspended particulate matter. Then what is the method for what the measurement of the suspended particulate matter? Firstly, take a filter paper, that is what pre-weighed filter paper, which is washed, dried filter paper, and pass the air for a specified period of time. It may be 1 hour or more than 1 hour, as depending upon your air volume. Then weigh the filter paper before and after passing the air through the filter paper, and then whatever the gain in weight of filter paper is measured, and this gain in weight is divided by means of the total volume of gas passed through it, and gives the suspended particulate matter in the parts per volume. So, what is the formula for that? Suspended particulate matter in milligrams per centimeter cube is equal to milligram of weight of suspended particles, that is nothing but gain in weight, divided by total volume into 0.02837 is the Watt conversion factor. In this way, we can determine the suspended particulate matter in the given air. Next, second is the settled particulate matter. Then in settled particulate matter, we are going to learn in detail how this sampling is done and how to determine the different types of settled particulate matter in the air. The settled particulate matter includes mainly solids and tar, that is coal tar. So insoluble solids, soluble solid, and tar and soluble ash, all these are included in the settled particulate matter. First one are the sampling, how to sample the a given air for the analysis of the settled particulate matter. Polluted air samples are collected in a selected representative areas in a wide mouth glass or plastic vessels, usually kept at 40 to 50 feet above the ground level. Water up to 2 liters is kept in the vessel, and the vessel is kept about for 1 month for any specified exposure of period. How the sampling is done? The polluted air samples are collected in a selected representative areas in wide mouthed glass or plastic vessels, usually kept at 40 to 50 feet above the ground level. Water up to 2 liters is kept in the vessel, and The vessel is kept about 1 month or for any specified exposure period. After this, determinations is carried out after sampling. The insoluble solids is determined by means of the insoluble solids are determined by filtering the water collected in a vessel which is exposed to the air. So, the insoluble residue after filtration is collected on the filter paper. The insoluble residue along with the filter paper is dried at 105 degrees Celsius for 1 hour and weighed as the insoluble solids. What is the method for determination of insoluble solid? The insoluble solids are determined by filtering the water collected in a vessel which is exposed to the air. The insoluble residue or after filtration is collected on the filter paper, and the insoluble residue along with the filter paper is dried at 105 degrees Celsius for 1 hour and weighed as insoluble solid. So this is a simple method to determine the insoluble solids. What we will have to do? The exposed water is get filtered by means of filter paper, and this residue, that is what the solid, insoluble solid, is collected on the filter paper, and this filter paper residue, insoluble residue, is what dried at about 105 degrees Celsius for 1 hour and it is weighed as a insoluble solid. Then second determination is the tar. The water sample which is exposed to air is extracted with the CS2 solvent, and the water experiences the weight loss, and then the loss in weight of the water after extraction with CS2 solvent is taken as an amount of tar. So what is the method for the determination of tar? It is what? The extraction method, because the what exposed water with air is what extracted with the CS2 solvent, it is organic solvent. Then the tar is get associated with CS2, and the water fills the weight in loss in the weight, and this loss in weight is nothing but the amount of tar present in the given air. So next determination, third determination, is what? Soluble solids. Then the filtrate after determination of insoluble solid is diluted to a known volume. A known liquid, say 100 to 200 ml of it, is taken in a previously weighed evaporating china dish. The filtrate taken in china dish is evaporated to dryness, dried to 105 degrees Celsius, and the residue is weighed as a soluble solids. It is a very simple method to determine the soluble solid in the given air sample. That is what? The water is exposed to air. Take a filtrate after determination of insoluble solid is what? Diluted to a known volume, and a liquid from that portion of from that is taken. That is what? 100 to 200 ml of it is taken in a previously weighed evaporating china dish. Then filtrate taken in china dish is evaporated to dryness, and dried is about what? 105 degrees Celsius, and the residue is weighed as a soluble solid. So this is nothing but what? The soluble solid. What is resulting weight is nothing but the soluble solid. Then fourth determination is the what? Soluble ash. Ignite a known weight of a soluble solid residue for about 1 hour at 500 to 600 degrees Celsius. The weight of ash is left after ignition is taken as a soluble ash. So whatever the soluble solid will obtain from evaporating the solvent, this is what get ignited about what? 500 to 600 degrees Celsius. Then whatever the weight of this ash is taken, this is nothing but soluble ash. So this is about the determination of the settled and suspended particulate matter. So next is the what? The determination of sulphur dioxide. that is what SO2 in a air by calorimetric method. So this is the simple Westgate method used for the estimation of SO2 in air. So Westgate method of estimation of sulfur dioxide SO2 in air by calorimetric method. What is the principle? It is very simple. It is what the colorimetric measurement is there. We measure the color of the compound, and with the help of this color intensity, that is optical density, we are able to measure the concentration of given SO2 in a given what the sample of air. So the sulfur dioxide SO2 in air forms a red-violet colored complex with para-rosanilin hydrochloride. So HCl mixture, and that is what formaldehyde. The colored complex shows the maximum absorbance at 560 nanometer wavelength. What is the principle? We are going to what form complex of SO2, that is sulfur dioxide, with para-rosanilin hydrochloride and what the formaldehyde, the mixture of para-rosanil hydrochloride and the formaldehyde. The colored complex shows the maximum absorbance about what 560, that is 560 nanometer wavelength, that is lambda max. The color intensity of the complex is directly proportional to the concentration of SO2 in air. So whatever the color intensity, as the absorption is directly proportional to concentration, as we know that from the Beer-Lambert's law. It is what the absorbance is directly proportional to the concentration. So as a concentration increases, the absorbance increases. So the amount of SO2 in a given sample is directly proportional to the color intensity. So hence, by measuring the optical density of the sample, colored complex against the standard color complex obtained from a series of standard solutions prepared by using sodium bisulfide in a sodium tetrachloromercurate, the concentration of SO2 in air is determined. Is what we are going to plot a graph, that is what the calibration curve, by using a standard solution of, by measuring the optical density of the standard solution, which is prepared by means of the what standard solution prepared by using sodium bisulfite in sodium tetrachloromercurate. So the series of solutions were prepared, and by measuring their optical density, and we can after getting the readings, we can able to plot a graph, that is calibration curve, and with the help of calibration curve we can determine the concentration of SO2 present in a given air sample. So what is the method? The air sample containing SO2 gas is bubbled through a absorbing solution containing sodium tetrachloromercurate, which absorbs the SO2 gas in it. So what is the method? The air sample containing SO2 gas is bubbled through a absorbing solution containing sodium tetrachloromercurate, which absorbs the SO2 gas. So what we will have to do? Simply pass the SO2 gas to the solution of sodium tetrachloromercurate, which traps the SO2 in it. So the solution containing SO2 is then allowed to react with formaldehyde and then with para-rosanilin hydrochloride reagent. Then a red-violet colored dye complex is formed. The optical density of the colored complex is measured at the lambda max, that is what 560 nanometer wavelength. So after what the absorbing this SO2 is allowed to react with formaldehyde and with the what mixture of para-rosanilin hydrochloride reagent, then we will get the red-violet colored dye complex, and the optical density of color complex is measured at the what 560 nanometer wavelength. In the meanwhile, a series of standard solutions of sodium disulfide in sodium tetrachloromercurate solution are prepared for the what the making a calibration curve. What is the procedure? In the meanwhile, what performing this what absorption of SO2, bubbling of SO2 and reacting of SO2 formaldehyde in with para-rosanilin hydrochloride reagent During carrying out this operation, was simultaneously carry out the series of standard solution of sodium disulfide in sodium tetrachloromercury solution are prepared, and with varying concentration of SO2, each standard solution is allowed to react with formaldehyde and para-aniline hydrochloride reagent to form a red-violet colored complex. Then optical density of all the series of standard solutions are measured in the colorimeter at 560 nanometer wavelength. A calibration curve is prepared by plotting optical density versus concentration of SO2 in a series of standard solution. After this plotting the graph, we will get such type of plot, and with the help of unknown concentration, that is what with the help of optical density on this axis, if we plot the normal to the unknown concentration, here what the unknown concentration of SO2 in air, and after what plotting the normal, we can get the concentration on the x-axis, and with the help of this we can finally estimate or judge the amount of SO2 present in a given solution of sample of air. Finally, from the optical density of unknown and calibration curve, the concentration of SO2 in air sample can be determined. So this is the way to measure the concentration of SO2 present in a given sample of air by means of the colorimetric method. Then what is the actual procedure for the determining the the SO2 concentration in the air by Westgate method, spectroscopic method? See, the modified Westgate spectrophotometric method remains the standard method for monitoring 0.005 to 5 ppm of SO2 in ambient air. So figure illustrates the sampling train employed to draw the samples from air. How to sample is taken from the air of that is what sampling of air is shown by means of the apparatus. So the SO2 is collected in scrubbing solution containing that is what HgCl4, HgCl2 plus KCl. The collection efficiency being around 95%, the solution is allowed to react with formaldehyde and then with para-aniline. Then with the help of this, it is the SO2 is react with absorbs over the HgCl4 twice SO2, then it H2, that is Hg2Cl2 SO3 twice 2H, and then it reacts with formaldehyde, and with reacting this with formaldehyde we will get the SO3H, that is the acid, and after this it reacts with para-aniline, and this forms a complex with para-aniline, and that complex or red dye is dye is formed, and the red violet dye is formed, such dye form, and this red violet dye having the absorbance, that is what lambda max is about what the is measured at about what the is about lambda max is measured at about where is the lambda 560. So 560 nanometer is the lambda max, and at that maximum wavelength we can measure the absorbance, and we will get the absorbance is about 548 nanometer for that, and block diagram for continuous SO2 monitor based upon the Westgate method and developed by Technico in the form of the Technico air monitor instrument is shown in figure. So what is the determination of SO2. How SO2 is determined with the help of what? The Westgate method. So this is about the determination of SO2 in the air sample by Westgate method. If you have any query regarding this estimation of SO2 by Westgate method, please comment in the comment box of YouTube. I will try to give the answer. So the major interference during the measurement of this SO2 is the NO2, which is present, that is less than 2 ppm, then present in the eliminated by additional sulfanic acid is added, and this reagent acts as an reducing agent, converting NO2 to N2. They pump up the 30 to 6 liter of air through the 10 ml of this scrubbing solution, that is 13.6 gram HgCl2 and 7.5 gram KCl, 1 liter water in a small impeller at 1 to 2 liter per minute. Then add 1 ml dilute para-rose-aniline reagent solution, and after that that is how this para-rose-aniline is prepared. 4 ml of 1% aqueous solution acidified with 6 ml of concentrated HCl and diluted to 100 ml with water, and 1 ml of 0.2% formaldehyde solution, and after 20 to 30 minutes measure the absorbance at about 560 nanometer. Use the dilute solution of sodium thiosulfate checked audiometrically as a standard. See, this is the train used for the sampling of sulfur dioxide. How sample is taken, weight impedure, and this air is passed to this, and hypodermic needle, and the filter here, the air pump for the taking sample, and this is the overall instrumentation for the determination of sulfur or estimation of sulfur by means of Westgate method. Air is passed by absorbing reagent, that is mercury chloride, and then after mixing with this, and then the gas liquid separator is there, the sample here the N2 gas is get separated from the SO2, and then sample of air for mixing, and then here we add sulfanic acid for the separation of the N2, then formaldehyde is added, then mixed with this mixture is made and with SO2, and then after that para-rose-aniline hydrochloride is added, and then mixed about 45 degrees Celsius. We will get the dye here, and after getting dye we go for the colorimetric measurement, and we will get the absorbance. So the Westgate method for the determination of the SO2. The another one is a Titometric method is there for the SO2. From air is trapped into an impeller containing dilute H2O2 solution. Then SO2 is converted into H2SO4. The resulting H2SO4 solution is titrated by means of against the standard NaOH solution, that is 0.002 normal, using methyl red or methyl orange as an indicator. And with the help of this formula we can calculate the amount of SO2 present in a given sample, that is from the volume of 0.002 normal NaOH consumed by known volume of SO2 in air. The concentration of SO2 in air is calculated. Whatever the amount of that is NaOH get consumed is equal to the amount of SO2 present in the air. So SO2 in ppm is calculated by means of volume of 0.002 normal, that is NaOH is consumed into normality of that 0.002 into temperature into 10 and divided by the volume of air, we can determine the amount of what SO2 present in a given sample. This is what the Titometric method, which is what alternative to the Westgate method. So thank you, thanks a lot. If you have any query, any questions regarding this, please comment in a comment box. I will try to answer this question. Thank you.